So we're going to use the graph of 2 to the x. So in your head, you have 2 to the x. We'll just draw it quickly here. We have y equals 0 as the asymptote. And we're going to have the point 0, 1, and 1, 2. This is the graph of y equals 2 to the x. And we want to graph y equals 3 times 2 to the negative x plus 2. So first of all, I'm going to rewrite it, and while I'm rewriting it, I notice that where the x is, that's all your horizontal stuff. Does it make sense then? I'm going to just label this already. This is going to be a vertical stretch. We're going to multiply our y values by 3. Then we have a horizontal reflection and a horizontal translation. I know it was a long time ago, but do you remember that anytime you have a horizontal stretch or reflection and a horizontal translation, that you need to write it in factored form. So this would have to be written like that. Then sometimes what I do, and one of the reasons that we didn't do exponential functions in our first chapter, is they're a little bit tricky because the parent function has a number in it. And that number can throw you off. Because sometimes people want to do 3 times 2. Okay? Careful, order of operations. You know BEDMAS. Exponents happen before multiplying. This has an exponent. But you're going to be tempted because the 3 is so close to that 2. You're going to be, oh, that 3 and that, wouldn't they be nice if they got together and made a 6? You're going to be so tempted by that, but no. We have to do order of operations. Exponents have to happen first. So we can't multiply. Also, you're going to be tempted to point at this 2 and say, this is a vertical stretch. No. That's what makes it a little bit hard. The 2 and the x, I'll highlight them. They are not transformations at all. Those are your parent graph. That tells you what the original blue graph was. It tells you points on your original blue graph. They don't affect your transformations whatsoever. The only thing that affects your transformations, there's a 3 outside, that's vertical. We have a negative inside, that'll be a horizontal reflection. You'll multiply your x value by -1. And then we have a horizontal translation, 2 to the right. Remember that x's are liars. And then to find out what our graph ends up being, we take our 2 original points and our asymptote. Do stretches and compressions first. So we're going to multiply our x by a -1 and our y by 3, and do translations second. So this will be 0 and -1, and this will be 3 and 6. Then 2 to the right, this will be 2, 3, and this will be 1, 6. And then the asymptote is interesting. Because it's at 0, your original asymptote is at 0, multiplying won't affect it. So multiplying anything won't affect it. The only thing that's going to affect a horizontal asymptote is if you shift it up or down. Does it make sense that here it goes on forever? If you move something that goes on forever horizontally left and right, no one will ever notice. It'll still go on forever at that point. So in this situation, since we're moving to the right, our asymptote is going to stay exactly the same place it was. So now, we'll have a look at this graph. I have the point 1, 6. I have the point 2, 3. And I have an asymptote still at y equals 0. Based on these 2 points, it has to go down towards the asymptote and it'll go up forever in this direction. Can you see the horizontal reflection happen? So, to answer the questions, is it increasing or decreasing? Our final graph is decreasing. There's no x-intercepts, because we have an asymptote there. If we wanted to find the y-intercept, one of the ways you could do it algebraically, because it's not showing up on my graph, I know it's going to hit there eventually, but I can't see from my graph, so I can plug in 0 for x. If I plug in 0 for x, you see that the exponent becomes a 2. Negative 0 plus 2. 2 squared, do that first, that's 4, times 3. My y-intercept will be 0, 12. Asymptote is still at y equals 0. The domain is still everything. And our range is bigger than 0, but not equal to 0. All right, I'm going to add a couple of more examples of graphing for you. So you can do one on the bottom of page 346. Or maybe I've got pages. Yeah, I'll do one more for this. Yeah, I did this on the bottom of page 346. So graph y equals negative 5 times 3. I'll put it in factored form already. So on an exam, you might get this, and it doesn't tell you what the parent graph is. So the first thing you have to recognize is, what is the parent graph? And it's going to be, I'll do it in the purple, what's the base? The base is 3. So if I took my highlighter out, I might highlight the 3 and the x, just to remind myself that those aren't transformations. That's my parent graph. And I can draw a quick sketch of my parent graph. In purple. I know that it goes through 0, 1, and 1, 3, and it's an increasing one. So those will be, and then I look through and see stretches and compressions first. Do you see that you're going to multiply that 2 is going to multiply your x by a half, and the negative 5 is going to multiply your y by a negative 5. Then the plus 4 is going to go 4 to the left, and the minus 7 is going to go 7 down. So again, this is just a review of our very first chapter. Can we say where those points will go? Well, multiply by a half, this will be 0 and a half. Multiply by negative 5, and negative 15. 4 to the left, minus 4, and minus 3.5. 7 down, minus 12, and minus 22. And the only thing that's going to affect your asymptote is if you move things up or down. Did we move things up or down? Yes. We moved 7 down. So our asymptote's going to be at minus 7. So if I draw, minus 10, minus 20, then I would have minus 7. And I'm going to have the point minus 4 minus 12. And I'm going to have minus 3.5 minus 22. Now, according to that, that would mean it would have to go towards the asymptote on this side and down on that. On my final graph, I have 2 points labeled. Those 2 points will show all the stretches, compressions, translations. I've got my asymptote label. And this will be on the exam always worth 4 marks. They give you 1 mark per transformation. So do you see the negative? Then they give you a mark. Is the stretch by 5 there? Is the stretch by a half there? So they check your 2 points to make sure they're there. Do you have your left and right, up and down values there? Then you're going to get 4 out of 4. So hopefully by the time you get to your exam, these transformations, you're like, I'm getting really, really good at them, because they're often worth quite a few marks. Okay. And today is an exciting day because I get to introduce you to a new number. The new number you're going to learn today is, and now you think I've lost my mind completely. You're like, Mr. Jared, that is a letter. That is not a number. But no, for today, it is a number. Can you find the number E on your calculator? And can you push enter and find out what it's approximately equal to? It is a number. They should have used a Greek letter. Then you'd be like, nobody gets mad at pi, because most of you don't speak Greek, so you're not like worried about the Greek alphabet. But can you find the number E on your calculator? And if you push enter, did you get 2.71828182828?
Repeat or it ends at that date?
It keeps going. Okay. What do you think the next number is?
182.
It's not. It sure looks like it should keep going. 1828, 1828. It seems like, oh, this isn't. No. It is as crazy and random as pi. Great. It is another. It just happens to be way easier to memorize the first 9 digits of E than it is to remember the first 9 digits of pi. Because it seems to have a pattern. But then after that, it keeps on going, but it doesn't follow that pattern anymore. This is the number E, and it's very important in exponential graphs. So what we're going to do next is we are going to graph y equals e to the x. I think you have a blank page on page 357. And if you're graphing e to the x, it's not hard, because all exponential graphs have 0, 1, and this one would have 1, e. Wonderful. Still has an asymptote at y equals 0. Now, if you have the graph of y equals e to the x, again, you might want to take out your highlighter and say, okay, so that is my parent graph. E and the x. So for transformations, then, this 3 outside, going to multiply your y values by 3. The minus 2, you're going to go 2 to the right. The minus 1 outside the function is going to go 1 down. And you could take your points, 0, 1, and 1e, and your asymptote, and see where they go. It actually becomes like, if you take the point 1 comma e, very fun to say this in the English language, because what happens when you multiply by 3? You get 1 comma 3. Just different than 1 comma 3, right? This is 3. And then you subtract 1 and you have 3 comma 3 minus 1. That should not be a 3 there. Oh yeah, because we went to the right. 3 comma 3. And then you could plot those in the 3 minus 1. You'd have to estimate what that, knowing that e is about 2.7. 3 would be about 8.1. Minus 1, this would be about 7.1. So you have to get a somewhat of an estimate where it would be, and then you can draw the graph. And you can circle questions 10 and 13.